So, good morning to all of you. Welcome to my lecture 4. Myself, M. Soundararajan, Assistant Professor from Department of Agricultural Engineering at Sri Shanma College of Engineering and Technology. So, in this lecture, we today going to see the two basic important physical properties that are soil porosity and soil density. Yes, you can see the topics in this slide. Yes, this lecture explains the key concepts of soil porosity and soil density in agricultural engineering. The detailing the definitions, formulas, and significance of bulk density and particle density, and also soil porosity. We're going to see in this lecture. So, yes, soil density and porosity are crucial physical properties of soil that affect water movement, root growth, and overall soil health. The These content is prepared by myself. So, okay, we can move to next slide. First of all, we're going to see that bulk density. Yes, yeah, I given the definition for bulk density. You can see it in this slide. Yes, bulk density is denoted as rho V. Bulk density is defined as the mass of dry soil per unit volume, which includes the pore spaces. That means air and water voids are involved in the calculation of bulk density. It is the measure of how tightly packed the soil is. So the formula for calculating the bulk density is mass of oven dry minus dry soil divided by total volume. So the common units for bulk density are gram per centimeters cube, or we can use the unit megagram per meters cube. Okay, we can move to next slide. Here I given the typical bulk density values for different types of soils. You can see that values of bulk density for different soils. The first one is the slide. This slide provides the common ranges for bulk density based on soil texture. Yes, the first soil is sandy soil. It has the bulk density ranges from 1.4 to 1.7 gram per centimeters cube. The values should be denoted in, so the values are in gram per centimeters cube. So we have to read like that, not in megagram per centimeters cube. So the values given in this slide is in the values in unit like gram per centimeters cube. Then the sandy soils have the more compactions. They are density level. So the second one is the loamy soil. It has the bulk density range from 1.2 to 1.5 gram per centimeters cube. So it has the moderate compaction. Next one is the clay soil. Clay soil having the bulk density range from 1.0 to 1.4 gram per centimeters cube, as well as it has the less compaction than the other two types of soil which is above this. Then final one is the organic soil, that is having the bulk density range from 0.5 to 1.0 gram per centimeters cube. So it has the very low density or compaction when compared with all those soils above. Okay, we can move to next slide. Yes, in this slide we're going to see that factors affecting the bulk density. These slides list the factors that can cause bulk density to change. So first one is the soil texture and particle size distribution means it affects how soil particles can arrange themselves. The second one is the organic matter. An increase in organic matter generally decreases the bulk density, as organic matter is lighter than mineral solids. Third one is the compaction. So compaction from machineries or traffic, this increase the bulk density by pressing soil particles closer together and reducing pore spaces. So the final one is the depth in soil profile. So bulk density generally increase with depth due to the weight of the overlying soil. So these are the factors that are affecting the bulk density. So in next slides, we're going to see bulk density, sorry, particle density. We're going to see in this slide. Here, given the definition for particle density. So this slide defines the second type of soil density. Yes, there are two types of density. First one is the bulk density and second one is the particle density. We have seen already bulk density and definitions and formulas we have seen about for the bulk density. So in this slide, we're going to see that particle density and what is the definition for that and formula for particle density. So the particle density generally denoted as rho p. Particle density is the mass of soil solids per unit volume, but this measurement excludes the pore spaces. It is the density of the actual solid material only. The standard value for the most mineral soil is approximately 2.65 gram per centimeter cube, so which is the density of common minerals like quartz. So organic soils having the particle density is typically lower for organic rich soils, ranging from 1.4 to 1.8 gram per centimeter cube. Okay, then we can move to next slide. So here I given the definitions as a difference between the bulk density and particle density. So these slides contrast the two key density terms. The first one is the bulk density, that is denoted as rho v, and the particle density, that is denoted as rho p. The bulk density includes pore spaces, but particle density excludes only solid particles. So it excludes the pore spaces. Uh, while calculating the bulk density, we omitting the pore spaces in the measurement or calculation. But in the particle density measure determination, we are excluding the pore spaces, but we are only including the solid particles to find out the particle density. So bulk density is affected by compaction and structure, but at same time particle density relatively constant for mineral soils. Okay, we can move to next slide. So this slide is deals with soil porosity. So here I given the definition for soil porosity. You can see in this slide. Yes, this slide defines the concept of this slide defines the key concept of soil porosity. That is denoted in small alphabetic letter n. The soil porosity is the percentage of soil volume that is occupied by the pore spaces occupied by air and water. So it is directly calculated from the two densities. The formula to calculate the porosity is porous but in the percentage. The porosity in percentage is equal to 1 minus bulk density divided by particle density, which is multiplied by the 100. So this is the formula for find out the porosity in percentage using the two types of bulk densities. So two types of densities, that are bulk density and particle density. So in next slides, we're going to see the different types of soil pores. Yes, you can see. The soil porosity is composed of two main types of pores organized by the categorized by their size. So the first one is the macro pores. Macro pores are generally are large pores that are greater than 0.08 millimeter in the so the macro pores allow for high movement and rapid water drainage. At the same time, micropores are uh, small pores that are less than 0.08 millimeter. So micropores hold water against the force of gravity, making water available to plants. So total porosity, final one is the total porosity. Total porosity means the sum of macropores and micropores. Okay, you got it, this concept. So we can move to next slide. Next slide, we're going to see the typical porosity values for the different soil. Yes, I listed here four types of soils and their porosity values. This slide shows how total porosity varies by soil texture. So sandy, first one is the sandy soil. Sandy soil having porosity value ranging from 35 to 50 percentage. That creates the tend to have larger pores and better drainage. The second one is the loamy soils. Loamy soils having the porosity value from 40 to 50 percentage that offer a balanced distribution of pore sizes. The next one is the clay soils. Clay soils having the porosity value from 45 to 55 percentage that that often have smaller pores leading to slower drainage in the clay soils. The final one is the organic soils having the high porosity value that is 60 to 80 percentage. That means it have the highest porosity value. Okay, we can move to next slide. Next slide is talking about the void ratio. So here I give even the definition for void ratio and formula to find out the void ratio. So this slide introduces an alternative measure of the proportion of voids in the soil. So void ratio is denoted in a small alphabetical letter E. So void ratio is the ratio of volume of voids to the volume of solid, volume of voids to volume of solids. So that means here the volume of void means pore spaces and the volume of solid means soil particles. The formula for find out the void ratio is E equal to volume of voids divided by volume of solids. So the relationship to the porosity N, in order to relate the porosity with a void ratio, there is a derived formula given here. The void ratio and porosities are interchangeable measures related by the formulas. So here I given the formula E equal to N divided by 1 minus N and N equal to E divided by 1 plus E. This formula relates giving the relationship between the porosity and void ratio. So yeah, I have to note that mark the volume of voids. Volume of void means that pore spaces. Pore spaces in the soil profile, soil. So at the same time, volume of solid means solid particles. Solid particles means soil particles. Okay, this formula giving the relationship between the uh, void ratio to N means porosity. We have seen about that porosity in previous slides. Okay, we can move to next slide. In the next slide, we giving the relationship between the density and porosity. So it summarizes this slide summarizes the core the relationship between the density and porosity. So in soil density and porosities are inversely related. So if the high bulk density means there is low porosity in the soil. So that give the characteristic of the compacted soil. Then in the characteristics of loose soil, if there is low bulk density, means there is a high porosity. So as the compaction increases, the pore volume will decreases in that soil. So in the next slides, I given the sample problem. Here in this slide, I given the worked out problem to find out the porosity. Yes, this you can see the datas in this problem. The soil type is sandy soil, and the bulk density is given in the problem, that is 1.4 gram per centimeter cube. Then particle density also given in the sample problem, that is 2.65 gram per centimeter cube. So here we are using the porosity formula, the porosity in percentage, that is 1 minus bulk density divided by particle density, that is multiplied by 100. So we have to put the values on it, 1 minus 0.528, and that that is we have you can put the values on the formula, that will come like this. 1 minute, I will mark that. Yes. So in that we have put the form values on that formula, that it is a bulk density value, it is the particle density value. So you can use the calculator to solve this question, that you will get that 1 minus 0.5 something. You can check on calculator. It's 0.528, that is the value you can get from 1.4 divided by 2.65 portion. So you will get the one, it will come like that same one. Then this portion will be like 0.528. This whole time is multiplied by 100. This 100. This will come like that 0.4 something. You can check on the calculator. Yes, 0.47872 will come. That is multiplied by 100. So finally you will get this value. This is the porosity value for this sample problem. Okay, we can move to next slide. Yes, in this slide you can see the importance of soil porosity. So soil porosity is affecting the uh, soils in different ways, and it affecting the plants also in different ways. Yes, this slides highlighting the why maintaining good soil porosity is essential for agriculture and soil health. The first one is the water dynamics. The water dynamics important for water infiltration. So water infiltration means how water enters through the soil. And the storage capacity. The storage capacity means how much water the soil can hold. So these things are can be influenced by soil porosity. The next one is the plant growth influenced by the soil porosity. So plant growth is essential for root penetration and growth, as roots need open channels to move through the soil. The third one is the gas exchange, also influenced by the soil porosity. So the gas exchange is critical for soil aeration and gas exchange. That means providing oxygen to roots and soil organisms. The soil porosity also influence the nutrient cycling in the soil. That means influencing the microbial activity and nutrient cycling, as microbes thrive in well aerated soil. So next slide we're going to see the measurement methods for soil porosity. Yes, in this slide I listed three types of measurement methods that are core method, cloud method, and excavation method. In the cloud method, we are extracting the undisturbed soil samples from the soil. So in the core method, we are extracting the undisturbed soil samples of unknown volume soil. This commonly used to measure the bug density. And the second one is the cloud method. Cloud method, we are using the wax coated soil clouds to determine the volume by displacement. Then the third one is the excavation method used for large scale or field measurements. So in next slides, we're going to see the porosity assessment methods. Here I listed the three types of porosity assessment methods that are water drainage tests, laboratory analysis, and calculation methods are used to assess the porosity. The first one is the water drainage method. That means water drainage test. It is a simple field method to estimate pore connectivity and drainage rate. And the second one is the laboratory analysis method. Uh, So laboratory analysis used for precise measurement of pore size distribution, for example, using pressure plates or porosimetry. Then third one is the calculation method. The most common approach is the calculation method used to find assess the porosity. The calculation method using measured bulk density and particle density values to find out the porosity. Yes, we move to yes we came to final slide. So thank you for your listening. So I hope that you can understand that today's topics and concepts. I will come up with new topics in next lecture number 5. Thank you.